we have discussed about the criteria of good estimator. It should be what are the criteria for good estimator? It should be unbiased, consistency and efficiency and sufficiency. We have done many problems on unbiased, efficiency and consistency. Sufficiency, I'll give you the definitions. The problems are not much important. So I'm just going to the next topic called methods of estimation, which are nothing but we have three methods of estimation like maximum likelihood estimation, method of moments and principle of least squares. Principle of least squares we have already discussed in the unit 1. These two we are going to discuss in detail. So what do you mean by methods of estimation? As I said you that you'll have two characteristics called parameters and statistics. Population constants are called parameters and sample constants are called statistics. Now, as always parameters are unknown, we estimate those by using the corresponding statistics. So how do you estimate? How do you estimate that sample mean? You are saying that check whether sample mean is an unbiased estimator. So for mean can be estimated by median, mode or any other measures of central tendency, but we are using only sample mean. So how can you initially say that sample mean can be an estimator of population mean? So the means we have different methods of estimating a parameter. So we have those three as maximum likelihood estimators, method of moments. These two are expected long answer questions. Okay, unbiased, efficiency, sufficiency. If you get as a single question means you will get for short answer. By combining two you will get for long answer. Whereas MLE itself is a long answer. Method of moments itself is a long answer question. Now maximum likelihood estimation. Let us discuss about MLE, which we call as maximum likelihood estimation. How do you find out an estimator using this method? So let us see. Let us say that general you should write the procedure and problems also. Let us say that x1, x2, xn is a random sample from a population with parameter theta. Theta is the parameter which is to be estimated here. Okay, with PDF we write this with for PDF. Okay, but x1, x2, xn is a random sample from a population with parameter theta and PDF fx theta. What does this MLE majorly consists of? It involves three steps. First, what you need to write is you need to write the likelihood function, which is a new term for you. First write the likelihood function. After writing the likelihood function, you should find out the likelihood equation. And name itself tells that maximum likelihood estimator, you should maximize likelihood function. Not this one. This is second step. You should write the likelihood function and maximize the likelihood function. In the third step, by maximizing this, you will get an equation which is called the likelihood equation. Likelihood equation. Using that equation, we will find out the estimator for this. So, maximum likelihood estimator, the method of finding an estimator using maximum likelihood estimation method consists of three steps, which are nothing but writing the likelihood function, maximizing the likelihood function. After maximization, you will get an equation from this which is called the likelihood equation. By solving that likelihood equation, you are going to find the estimator for this. Generally, how do you, let us discuss the likelihood function. I said you that x1, x2, xn is a random sample from a population with parameter theta and PDF fx theta. Likelihood function is nothing but fx1 theta means x1 is the first observation here. Replace that with fx1 theta. What is the second observation? Fx2 theta. So on, what is the last observation? Fxn theta. Means we indicate if it is plus we write with sigma, all these are separated with multiplication. We write that with pi, fxi theta. Means first you will write the likelihood equation by taking the product of n number of PDFs. Then you'll maximize. This is the likelihood function. Now you need to maximize the likelihood function L. You need to maximize L. So you know that generally we deal with binomial, normal and Poisson distributions. All those PDFs are nothing but exponential type. So instead of maximizing L, for simplicity we maximize log L. Maximization involves dou log L by partial derivative you need to find out with respect to the parameter. Dou log L by dou theta is equal to 0. How do you maximize a given function? First derivative should be equal to 0. Second derivative should be less than 0. So this is called the likelihood equation. This is called likelihood equation. By solving the likelihood equation, we will find out the estimator. Again, I will repeat. Under methods of estimation, we have a list of methods, but we are going to discuss two methods called maximum likelihood estimation, method of moments. Coming to maximum likelihood estimation, it consists of three different steps: writing the likelihood function, maximizing the likelihood function, and solving the likelihood equation to find the estimator for the given parameter. So let us do a problem on this. The given problem is, let x1, x2, xn be a random sample from Poisson distribution with parameter lambda. Obtain MLE for lambda. Here it's a random sample from Poisson distribution with parameter lambda. You need to obtain the MLE estimator for lambda. So as I said in the previous problems also, as this is from Poisson distribution, you should write x follows p lambda. What is its PMF of Poisson distribution? E power minus lambda, lambda power x by x factorial, x from 0 to infinity. So specify the Poisson distribution, write the PMF. What is the step 1? I said writing the likelihood function. How do you write the likelihood function? L is equal to, if it is PDF, F, if it is PMF, Px. Px1 lambda, Px2 lambda, so on, Pxn lambda, product of n PDFs or PMFs. So e power minus x means you should replace x with x1. Lambda power x1 by lambda won't change, only x is going to change. Observe here, we are not changing the parameter, we are changing only the variable. The second one will be e power minus lambda, lambda power x2 by x2 factorial, e power minus lambda by x power n by xn factorial. You have e power minus lambda, e power minus lambda, e power minus lambda for n times, which you will get as e power n lambda. You have lambda power x1 into lambda power x2, lambda power xn by as x1 factorial into x2 factorial into now e power minus n lambda. As the bases are equal, you can add the powers, lambda power x1 plus x2 plus so on xn. If you observe the denominator here, all the variables are separated with multiplication, which we can write as pi I is equal to 1 to n. Pi stands for multiplication. So in the step 1, we should write the likelihood function, which we got as L is equal to e power minus n lambda, lambda power sigma xi by. Now step 1 is over. What is step 2? You should find maximize L, as it is maximum likelihood function. As I said you that instead of maximizing L, we are going to maximize log L. So first write down log L. Log A, it is in the form of log A by B. Log A minus log B. Again it is in the form of log AB, log A plus log B. Log e power minus n lambda plus log lambda power sigma xi minus log pi I is equal to 1 to n xi factorial. Again you can take this minus n lambda here, minus n lambda log e to the base e. You can take this sigma xi log lambda minus log pi, means you have written L. Since you need to maximize L, it consists of e powers and exponentials. Maximizing L will be difficult. So instead of maximizing L, we maximize log L. So find the simple expression for log L. So how do you maximize? Maximize means you need to find out the estimator for lambda. So dou log L by dou lambda should be 0 and second derivative should be less than 0. So let us write log L again. This is 1. Okay. This is sigma xi log lambda. As you are finding the derivative with respect to lambda, there is no lambda here. You can write that as constant with respect to lambda. As write L, log L separately. After writing the log L, identify that you need to maximize with respect to lambda. As we are considering lambda as the variable with which we are going to differentiate, the terms which doesn't involve lambda can be treated as a constant. So we wrote log L here. How do you maximize? Maximize is nothing but this is called the likelihood equation. This is called likelihood equation. So dou log L by dou lambda means you have dou by dou lambda of minus n lambda plus sigma xi log lambda plus constant with respect to lambda. So here you will get minus n, as this derivative of lambda with respect to lambda is 1, plus sigma xi log lambda derivative with respect to lambda is log x derivative 1 by x. As we are differentiating with respect to lambda, you will get 1 by lambda. Its derivative is 0. So minus n plus sigma xi by lambda, you got this one. As dou log L by dou lambda is 0, you will get minus n plus sigma xi by lambda is equal to 0. Minus n is equal to, or take the LCM here, minus n lambda plus sigma xi is equal to 0. You need to find out the expression for lambda. Minus n lambda is equal to minus sigma xi. Lambda is equal to sigma xi by n, which is nothing but x bar. So estimator for lambda is x bar. Okay. So the MLE estimator for lambda is x bar. Thank you.